Welcome back to Water Talk. I'm Paul the Waterman. So let me explain something real quick. Gray water is the water that comes from taking a shower and using your wash machine, or emptying the kitchen sink from doing a load of dishes by hand or the dishwasher. So, that's soapy, sudsy water that has all the dirt from the clothes and the dirt and food from the dishes. The other water, the black water, is water that to my understanding, comes, from the waste treatment plant after, it passes through and the solids have been dropped off, so to speak. And then, they treat it before they send it out to whatever location it goes to. And there's also the wastewater that comes from the filtration system in a water waste treatment plant. And so these are things that, a further discussion and study has to take place. And it's going to jump into my topic with, commercial reverse osmosis units for the purpose of water treatment, water filtration. And here's why I think they shouldn't be used. Reverse osmosis membranes are not designed to filter hard water. Reverse osmosis membranes are solely designed to filter water free from hardness. Then their nanofiltration is what captures the chemicals, the pharmaceuticals, and other organic or non-organic materials out of the water. Commercial reverse osmosis units, in most cases, it's not practical to pre-treat the water with a water softener, because then you have the wastewater from a commercial sized water softener that you would have to deal with in addition to the wastewater with the reverse osmosis. So what's happening is that reverse osmosis membranes, let's say you have a system that's a 30,000 gallon a day RO unit. So you have 6 reverse osmosis membranes for discussion purposes. The first 2 RO membranes could be used as sacrificial for where all the hardness is trapped and removed. The problem with that is that the hardness will then cause microplastics to become nanoplastics, because the plastics will bounce off the hardness, because the hardness will oxidize and will convert to a film. And then as water is so you have to understand that water is forced through a reverse osmosis membrane. There's a pump, and some of these pumps could be forcing it through at 12 gallons per minute to 22 gallons per minute. So when you're forcing water through, the membrane has no choice. It's just there, it has to take it. And so water is forced through it. And as the hardness builds up on those sacrificial membranes, then that's where the microplastics become nanoplastics. And then eventually what happens is that the membranes themselves will break down. And that's how they found nylon fibers in bottled water, was because of the manufacturing process. So reverse osmosis, in some cases, is, I think, the wrong application on a commercial side if you can't pre-treat the water. If you can pre-treat the water, then perfect, and that's what they're designed for. But I really think they should think about what they're doing if they're using a commercial reverse osmosis with hard water. And hard water, that's what happened to the bottled water industry. You guys remember, was it a year, 2 years ago, when there's news outlets doing stories about nanoplastics being found in bottled water, and then scientists that did studies would say, I'm not going to drink bottled water because of that, because it's because of the manufacturing process. And the Independent Bottled Water Association, instead of them telling everybody, hey, we appreciate these findings, we're going to look into it, instead of, and looking how bottled water is manufactured, instead of doing that, they basically said, well, there's really no studies, that to indicate what the harm really is. Well, let's jump forward to this year, and we played on this show a segment from Fox News, where now we have nanoplastics that penetrated into the human brain. So nanoplastics not only are in our water supply, we can also get them from food. We also, get them, when we wash our clothes. Certain fabrics, I guess, have plastic in them. So that's another avenue. So these are things that I really think we need to stop and take a look at. What we really need to do is look at the whole big picture of what we're doing with the quality of our water and water filtration. So back to the septic systems. When you take water and you send water, through, the drain, then what happens is the process of removing those solids, the waste, the human waste. And as the human waste is converted to biosolids, and the biosolids are then given away as fertilizer, something that we need to think about too is, testing these biosolids and seeing how safe they are because of the forever chemical contamination. So we've done, several shows regarding the forever chemicals, how they came to be with, DuPont and 3M. And then we also talked about how farms got contaminated, herds of dairy cattle had to be slaughtered because of the PFAS contamination, the milk was no good. We also did research showing that we had, over 20 million acres of possible contamination, farmland with PFAS contamination, which is also basically going to end up in our food chain, right, our food supply. So this is something that we really need to, take a bigger, broader look at. And then the other thing we have to look at, is what the heck we're going to do, excuse me, with the waste. Because human waste or biosolids, if it's not safe because of PFAS contamination, that's one issue. The wastewater that comes from water filtration at a water treatment plant, if we're injecting that into the ground and if that's going to end up back into the aquifers, then we really need to let people know about it. See, there's a water quality report that everybody is supposed to do. What I mean everybody, every single municipality that provides you water, if it's public or private, has to submit a water quality report to let you know exactly what's in your water. Now, I don't believe they're being 100% truthful and telling us everything that's in the water, and I think the reason why they're not doing that, in my personal opinion, is the fear factor. But we should be able to know what contamination levels we have. What's the actual pharmaceutical, element in our water supply? Now, we had a person who engineered aquifers on the radio show with Scott and I one time, and he told us that when they tested the water, every major over-the-counter pharmaceutical tested positive in that water source. And so I think that that's something that we should know about. So if that's the case, why isn't that on our water quality report? I've seen where little private water resources. All right, let me back up and say this again. Let's say you live out in a community that's controlled by an HOA, and it's a municipality that has, let's say 60 residents. And so you have to have a licensed water operator who basically ensures that the water is treated with chlorine. And then they are supposed to, treat the water and then have that water submitted for sampling, for testing, to make sure that the water, is within the EPA guidelines and treatments. So, I know for a fact that there's companies out there that are late in the testing and the reporting. And that's important because that's technically a violation. But then we also have an issue where the state lab is shut down now because we had the lab technicians that were falsifying water tests. Let's take a quick break, then we have a caller I want to go to.